All right, so as you take a look at these notes, domain and range are going to be ideas that come and go all year long. A domain, we're not going to be using that one as often during the first half of our year, but second semester it's going to be coming up a lot. Range, it's going to be a theme all year long, where you're going to have to remember what range is all about. Now, I gave you an example here of a graph. That example is a great way to be able to understand what we mean by domain and range, because domain, we describe it as all the possible x values. Well, this graph, I know there's no arrows on the end, but by this point, we often don't write it, even when it's assumed to go on forever. If you see the graph hitting the edge of the graphing grid, we just assume that it continues on forever in that direction. And so in this graph here, you can see that at all possible x values, so like for instance, if I go to -1, notice there's graph above it. If I go to -5, there's graph above it. If I go to -10, there's graph above it. If I went out here to -20, there would be graph above it. It would just be a long ways up. So at every possible x value, there is graph. That means that our domain for this example is all real numbers. And that's why it's all real numbers. But the reason why domain's not going to come up as often during the first half of this class is because basically for all the functions that we're going to be starting by looking at this year, it's going to be all real numbers. It's the second half of the year that it starts changing up a bit more. All right, range though. Range, well, it tends to vary and it tends to be something other than all real numbers. Range is always looking at our y values. So if I look at kind of all of these y values along here, I'm looking to see which of those have graph associated with them. So like up at 10, there's graph. At 6, there's graph. At 1, there is graph. Notice I'm looking at all the y values. But at 0, notice, there's no graph. No matter how far I go over, left or right, I do not hit graph on this one. And therefore, 0 is not part of the range. In fact, nothing below 1 is in the range. And so, that's why our range here is all of the y values. That's what we mean when we say y. We're meaning all of the y values that are greater than or equal to, and yes, you got to be able to keep it straight, which one's greater than, which one's less than. This one's greater than or equal to 1. Anytime the graph is going above that point, it is a greater than or equal to. If our graph started here and then it went down from there, it would be a less than or equal to. And that's going to be true every single time. Right, and then on this set of notes, we have something that is fairly familiar to a lot of you, is the idea of what a vertex is, and something that's probably less familiar in the axis of symmetry. I will tell you this definition of vertex, it is useful for our purposes right now. It's not 100% correct if we want to get super technical with higher level mathematics, but I'm okay with that for right now. Because it's going to work for everything we're going to be doing in here and helps us to visualize, which is what I need. So a local maximum or minimum. Local just means like in that area. It is actually the highest or the lowest point. So you'll notice here, I labeled our vertex on this graph as -5, 1. So you notice the point -5, 1 is right here. This is the vertex because in this area here, it is the lowest point. It's the lowest that it can ever possibly go. You'll notice here at the ends, this is not a vertex because this is not actually a local maximum. It kind of looks like it when we're first looking at it, but because it's reaching the edge of the graphing grid, all it means is that this just happens to be where we ran out of grid. The graph still continues on. We just aren't going to be able to graph something that's infinite, so we got to stop someplace. So vertex, generally speaking, is the highest or the lowest point. That's what you're looking for. The axis of symmetry, that's a little less intuitive. Let's take a look at that. Our answer down here, you'll notice, the axis of symmetry is given as x equals -5. That's actually an equation. I can graph that. If I graph x equals -5, think about, I have an x value of -5 here, I have an x value of -5 here, x value of -5 here, and so on. if you plot all of those points where the x value is -5, you end up with a vertical line. Anytime, nice general rule here, and a good one to make note of if you didn't know this already, anytime you have x equals just a number, that's going to give you a graph that is a vertical line. Every time. In this case, why is that the axis of symmetry? Notice to the left of that line and to the right of that line, it is exactly the same. So over here, if I treated this line like a mirror and took this side and flipped it across that mirror, I would end up with this. In fact, you can even do that with a graph. You can stand a mirror right between them on that axis of symmetry, and your graph will look identical as it did before you put that mirror down, because you'll still see the exact same thing on the left and on the right. That's what axis of symmetry is all about. So take a look at this graph, and I want you to just practice, find the domain, range, vertex, and axis of symmetry just from this graph, just from the picture. All right, so taking a look at this example here, we first want to figure out what is our domain. Well, in figuring out the domain, remember domain is all the possible x values. And so our x's, well, as I look along the x's, like here, there's graph. Here, there's graph. At all of these different x values, there's definitely a graph. But the question is probably, if anything's going to come up as a question, what happens, say, after I hit this point? What is the graph doing down here? Well, generally speaking, what you see with these types of graphs and these types of curves is that it's getting very, very steep along here, but it's not actually ever going to hit vertical. So it continues moving outward. It's just moving outward very, very slowly. So what that tells us is that if I go out here to 6 and I go down, eventually, if I go down far enough, I will hit graph. And those that keep going outward like that, no matter how far I go over, if I go down, I'm going to hit graph. Even if I go out here to like to 20 or whatever it is, I'm going to have to go down a long ways, but I'll hit graph. That means that our domain, yes, is all real numbers. Range. Well, the range is not going to be all real numbers here, because as I take a look at the range, like down here, this y value, yeah, there's graph there. At this y value, there's graph. At all of these different y values, there is graph until I get above my vertex. And so notice up here, there's no graph. That means I do not include this point in my range. All right, so to write out the range, I know my range is going to be my y values that meet some constraints. So I start by actually writing the y. Now, for my y values, they all need to be either above or below a certain number. Well, are they all going to be above or below this line? They're all below, right? Because that's where our graph lives. Since our graph lives below it, that means it is a less than or equal to. And then it's just a matter of what is it less than or equal to. So it's a matter of actually what is that y value? And it's a 6. And so y is less than or equal to 6. That's our range. Now we need our vertex. Now if it's a little bit hard to tell where the vertex is here, well, you can estimate, that's okay. But the nice part about doing this sort of thing on a computer is we can actually zoom in and take a look and see where that is a little bit more precisely. And so we can see here that our vertex is going to be at this point. That's the highest it reaches. Well, we need to first give our x-coordinate. That's how far we went over. Looks to me like that's going to be at -2.5. So that's the number I'm going to use there. And how far up? Well, that's a bit easier to tell. That looks like it's at 6. So I'm going to write then my vertex as a point, a coordinate pair, that is going to be at -2.5, 6. And then finally, the axis of symmetry. Notice there is an axis of symmetry here. If I actually wanted to visualize where that was, it'd be going just like this. That is the line where it's the same on the left and on the right. And so basically what I'm doing for axis of symmetry is writing the equation of that line. Okay, well, it's a vertical line, so I know it has to be x equals a number. What is that number? Negative 2.5.
Why negative?
And so notice, though, also one of the cool things about this is, do you notice some connections between some of these numbers? These connections are always going to be true with these, so I want to make sure you see these. The vertex is where we can really see it come up. Our vertex here, our x-coordinate was negative 2.5. Notice where else that number came up? It came up with our axis of symmetry. That is always the case because our graph is always going to be symmetrical around the vertex. And it's always x equals, therefore it's the x-coordinate. If there's an axis of symmetry, it's always around the vertex. And what about this 6? The y-coordinate of my vertex. You notice where else that came up? It's the range, which kind of makes sense because the vertex is the highest or lowest point. And if our vertex is up here at 6, that means all the graph must be either above or below 6 because it is the highest or the lowest point. And so those connections will always be true. So as you are doing your own types of problems like these, you should see connections between these numbers of range, vertex, and axis of symmetry. And it's a way you can kind of self-check as you go as well.